This is my solution to Paul McWhorter's picow series, lesson 98, the sweeping servo. PIO program is essentially the same one that Paul showed us in lesson 98 video, modified slightly to match the sample program shown in this manual Raspberry Pi Pico series PyCon SDK. I'll show you the cover. Here's the cover, and right here is where the sample program is. Notice where I've got my mouse hidden. Clicked. Let's take a quick look at the code. Before the state machine is active, it's primed the ISR with the period and the OSR and X register with the first PWM value. And the TX FIFO queue will be empty at that time. So this first pull no block, which also sets the pulse on the servo to 0, will not find anything, and the pull instruction in that case copies the X register to the OSR, so it's copying the same value to the OSR, and we turn around and that same value is copied into X again. So we've started a 0 pulse period. Y register is set to the whole period, and here we do the same thing that Paul did in lesson 98. We have a jump instruction that runs until X is equal to Y. So we're coming down from period to period minus the pulse width. And we will branch until it's equal. When it's finally equal, we've done a 0 cycle. And at that point, we turn the cycle on. We turn the period on, the pulse on. This always branches back to the time loop for the whole period. The net result is that, we'll see down here in the calculation, let me see if I can roll enough so we can see it. The two jump instructions each execute period plus 1 times. The remaining 4 instructions, the pull, the 2 moves, and the no-op, each execute 1 time. The total number of instruction cycles is 2 times P plus 6. Since P was 40,000, 20,000, that's 40,000 plus 6 instruction cycles. The state machine's frequency is 2 million, so each instruction takes half a microsecond. So those 40,000 instruction cycles take up 20 milliseconds, which is exactly what the servo expects for its period. The extra 6 instruction cycle take up 3 microseconds. So yes, we're off by 3 microseconds. However, we also are off by the value that we're using for the pulse width, since it was the truncated value returned by that get pulse width submodule above, truncated a floating point number to an integer. So I'd say we're close enough. Here's the same thing from my previous execution that I copied from Paul's video just for documentation, how that equation of the line to compute pulse width for angle. And here's my subroutine that I used. I added some documentation about it. For what's coming up now, we're going to be entering a loop where we're going to sweep the angle from 0 to 180 and back. So the delta of the angle in degrees is going to be 1, and we're going to sleep in between each time we change the angle to allow the arm to move. We define the state machine, or instantiate the state machine. Its frequency is 2 million. Period is 20,000. get the first pulse width, and here's where we prime the state machine. Hadn't even started it yet. We put the period and the pulse width into the TX FIFO, and then we prime the ISR, OSR, and X registers by executing some instructions. We'll do a pull that pulls the first value off the TX FIFO, which is the period, into the OSR. This move copies that value to the ISR. This pull pulls in the first PWM value and copies it to the X register, so both of them contain the same value, just like I stated above. Note now that the TX FIFO is empty, so that pull no block up in that code will just recopy the X value into the OSR. Alright, now we're at sweep time, or as I like to say, the glide of the broom. We activate the state machine, and we enter an infinite loop where we just start with the angle at 0 and go up by this increment, which was 1. We get the PWM value, we put it on the TX FIFO. Now that pull no block will find it. We allow the arm to move. When it reaches 180, we turn around and work our way down. And this accept should catch and allow us to terminate. So let's give it a try and see what happens. Notice the arm is moving from 0. And while it's moving, recall that I have this extra board on my board containing the servo because I'm running on a Raspberry Pi and it can't provide power to both the servo and my webcam. So we've gone from 180 and we're working our way back down to 0. I'm going to start up again and I'm going to cancel out. And we're done. Well, that was a fun exercise. I really enjoyed it. I hope you did too. Thanks for watching.